Hello everyone, my name is Abdul Hasid bin Sulaiman, and today I'll be talking about my final year project, which is privacy-preserving geofencing algorithm using Paillier encryption. Geofencing technology is everywhere today, from retail stores sending your offers when you walk by, to hospitals tracking patients safely. But there is a big problem. Traditional geofencing requires exact location, which can causing privacy risks. So the project goal is, how can we use geofencing without revealing user location? Traditional geofencing systems store and process raw location data, leaving users vulnerable to hacking, surveillance, and misuse. Even companies with good intentions can accidentally leak sensitive data. With laws like the UK GDPR, it's now critical to protect personal information like location. This new system benefits everyone who uses location-based services like businesses, hospitals, logistic companies, and most importantly, the users like you. Also, the organizations can still offer smart services without risking customer privacy. By preserving privacy automatically, companies can avoid massive fines for data breaches. They also save their reputation, build user trust, and stay legally compliant without spending millions on extra cybersecurity layers. Next will be the system design and the code structure. The system has three main players: the user, the server, and the client. The user is the person whose location we are checking. The server does the heavy computation, and the client owns the geofence. These are the flowchart of my system design. We'll be starting with the client. The client will define and convert coordinates to radians. It also will set their own geofence radius. After that, it will compute the coordinates to the trigonometric values. After compute, it will send partial trigonometric values to the user and the server. On the user side, it will define and convert coordinates to radians. After that, it will compute trigonometric values using the publicly plus client's partial trigonometric values. After compute, it will send the encrypted trigonometric values to the server. These are the functions of the code to convert coordinates to the radians. After that, these are the trigonometric values as per the protocol. And this line of the code is where Alice slash user will encrypt the trigonometric values using the publicly plus Bob slash client's partial trigonometric values. After that, it will be sent to the server to do the heavy computation. On the server side, we will calculate on user encrypted trigonometric values and client partial trigonometric values. After done with the calculation, we will send the encrypted result back to the client. These are the function of where the server will do the heavy computation, and then after that it will send the encrypted result back to the client. On the client side, client will decrypt the encrypted result using the private key, and after that client will compute the decrypted result into the Haversine formula, and finally the client can determine whether Alice is inside or outside the geofence. As you can see this is the function to check the Alice whether Alice is inside or geofence. First we'll be decrypting the result with the private key. After decrypting the result, we will then insert the result, the decrypted result into the Haversine formula to get the distance. Once we have the distance, we will be comparing with the geofence radius to determine whether Alice is inside or outside of the geofence. We will be running the code. Alice location is outside the geofence. This is in 0.00 km. As you can see here, we set the geofence radius is 0.39, meaning Alice distance is more than the geofence radius. So we also have put accuracy validation, which imported using Haversine library. The distance between Alice and Bob using Haversine library is 0.40 km, which is the same as Alice location, same as the distance as my encrypted implementation, meaning that my accuracy is valid. This is also the total time taken to do the process. After explaining my system design and code structure, we will go into my special security feature. To make it even more secure, I have fixed a known issue in the original protocol. I made sure that no sensitive trigonometric values are leaked, so attackers can't guess at anything about the user's real location even after repeated checks. Why is this matter? In a traditional system, user raw location are exposed to the server. In my system, all the location data stays encrypted. No one, not even the server, can see it. To summarize, my system achieves a real-time geofence detection with zero location leakage, solving one of the biggest privacy issues in today's tech world.